One of the laws of motion states an object in motion stays in motion unless unbalanced force acts upon it. On Earth, objects always seem to eventually come to a stop when more force is not being applied. What force is causing the objects to eventually stop moving? 2. Letter F, mass. G, friction. H, weight. J, gravity. Number 3. A 2,000 kilogram truck and a 500 kilogram car are racing. The same amount of force is applied to each of them. Which statement below best describes the acceleration of the vehicles? The truck will accelerate twice as fast. The car will accelerate 4 times as fast. The car will accelerate twice as fast. Or the truck will accelerate 4 times as fast. Number 4. When an object is acted on by an unbalanced force, the object will always F, accelerate, G, continue in the same direction, H, continue at the same speed, or J, come to a stop. Number 5. It takes a 7 Newton force to cause a 0.028 kilogram object to begin moving. What is the acceleration of the object as it begins to move? Number 6. A student pushes a box with a force of 16 newtons to the left. Another student pushes the same box from the opposite side with a force of 8 newtons to the right. According to the box above, information and diagram, what will be the result? The box will move to the right with an 8 Newton force. The box will move to the right with a 24 Newton force. The box will move to the left with a 2 Newton force, or the box will move to the left with an 8 Newton force. Number 7. The graph below represents the movement of an object. Which description best fits the motion shown on the above graph? An airplane taking off and reaching a constant cruising speed, a roller coaster traveling up and down the first hill, a car traveling at a constant speed and stopping to refuel, or a roller coaster traveling down a hill and climbing up the next. Number 8. A rocket booster initially applies 10,000 Newton force to a 1,000 kilogram rocket, causing it to accelerate 10 meters per second squared. 10 minutes later, the rocket booster is released and it falls through the atmosphere. The mass of the rocket is now 760 kilograms and acceleration is 7 meters per second squared. How much force is now being applied to the rocket? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. Number 12. A marble is rolling east along the floor at a speed of 0.5 meters per second. If a student exerted a force of 1 Newton towards the north, what would be the effect on the speed and the direction of the marble? The speed of the marble would be unchanged and the direction would be changed to the northeast. The speed of the marble would increase and the direction would change to northeast. The speed of the marble would be unchanged and the direction would change to the north. Or the speed of the marble would increase and then direction would change to the north. Number 13. In a series of controlled experiments, students measure the different forces acting on a skateboarder as he travels down a hill. Then, they calculate the skateboarder's acceleration for each of these forces. The student's data table is shown below. Forces acting on a skateboarder. The first example is 10 newtons of force, 0.25 meters per second acceleration. 12 newtons of force at 30.30 meters per second acceleration. 20 newtons of force at 0.5 meters per second squared. 30 newtons of force at 0.75 meters per second squared, 34 newtons of force at 0.85 meters per second squared, and question mark on force at 0.90 meters per second squared. Based on the observations and the calculations made by the students, what is the estimated force applied to the skateboarder if the acceleration is 0.9 meters per second squared? Record your answer and fill in the bubble on your answer document. Be sure to use the correct place value. Skip number 9, number 10. The table below shows the results of a student investigation. The speed of a toy car down a ramp. Distance 400 centimeters, speed 26 centimeters per second. 600 centimeters, 53 centimeters per second. 800 centimeters, 74 centimeters per second. 1,000 centimeters, 105 centimeters per second squared. Which of the following statements best explains the data collected by the student shown in the above table? The speed of the toy increases due to the forces greater than gravity. The speed of the toy car decreases due to balanced forces. The speed of the toy car increases due to unbalanced forces, or the speed of the toy car decreases due to friction. Two vehicles were involved in an accident. Vehicle A has a mass of 1,447 kilograms, and Vehicle B has a mass of 1,310 kilograms. Both vehicles were traveling at 20 kilometers per hour at the time of the collision. What will most likely be the outcome of this collision? Vehicle A will have no change in speed and be pushed to the left because it has a smaller mass. Vehicle A will have a change in speed and be pushed to the left because it has a larger mass. Vehicle B will have no change in speed and be pushed to the left because Vehicle A has a larger mass. Or Vehicle B will have a change in speed and be pushed to the right because Vehicle A has a larger mass. Number 15. A car travels at a constant speed of 70 kilometers per hour for 15 minutes. The car decreases its speed from 70 to 40 over the next 2 minutes and then continues to travel at a constant speed of 40 kilometers per hour for the next 5 minutes. Which of the following graphs best represents the car's motion during the given time period? Number 16. The diagram below shows a race car traveling around a racetrack at a constant speed of 150 kilometers per hour. At which point on the track is the car accelerating? Point A, point B, point C, or the car is not accelerating? Number 20. According to the graph above, what is the average speed of the car after 3 seconds? 30 meters per second, 15 meters per second, 5 meters per second, or 3 meters per second? Number 24. Student data. Time and speed. 0, 0, 1, 10, 2 seconds, 20 meters per second, and 3 seconds, 30 meters per second. Which graph below best illustrates the motion of the object based on the above data? Number 31. Observe the illustration above. If the student fell off the skateboard in the direction indicated, which arrow indicates the most likely direction the skateboard would travel based on the law of action-reaction? 1, 2, 3, or 4? Number 32. A force that will work against motion in every situation is the normal force, weight, gravity, friction. Number 33. You are riding in a vehicle with a coffee cup on the dashboard while traveling 30 kilometers per hour. The vehicle makes a sudden stop to avoid hitting the car that has stopped in front of it. Which illustration best demonstrates what would happen to the coffee cup? Go forward, go backward, stay stationary, go straight up. Number 34. Which of the following scenarios where a ball is in motion describes balanced forces? 1. A ball rolling down a ramp. 2. A ball rolling along the floor at a constant speed. 3. A ball falling forward. 3. A ball falling from the top of a building. 4. A ball on a rope rocking back and forth. Or 5. A ball spinning in place on a frictionless surface. Choices are 2 and 5, 2, 4, and 5, 1, 2, and 5, or 1, 3, and 4. Number 49. The diagram below shows the different 49. The diagram below shows different forces acting on a toy rocket. Gravity is 5 newtons. Friction of the air is 3 newtons. Friction applied or force applied is 15 newtons. The total mass of the rocket is 0.5 kilograms. Based on the information above, what is the acceleration of the rocket? 6 meters per second squared, 30 meters per second squared, 14 meters per second squared, or 46 meters per second squared?